Intermediate value theorem going on page 29 for AP Classroom. Again, if you are wanting to watch those videos or do extra things or whatever, that's the AP Classroom section that it goes with. I'm not sure who originally numbered these, and it's fine. I mean, it at least makes sense, but I think it's because we're putting a lot of their sections together. Okay, so this first thing says, suppose you were 4 foot 6 inches tall when you were 10 years old, okay? And now you are 5'7". Was there a time that you must have been exactly 5 feet tall? Okay, if you were 4'6", now you're 5'7". Is there a time when you were exactly 5 feet tall? Yes. Okay, how do you know? Constant rate? Okay, so do we grow at a constant rate? Do you grow like an inch every day or something? No. So since we don't grow at a constant rate, she said that's assuming that we grow at a constant rate, which we don't. So does that mean we can't guarantee that we were 5 feet tall at some point? Has to do with what? Continuity? Do you grow continuously? Okay, and no, but you grow some. Even if you stop, you're growing, right? And you're not like going backwards or anything, right? So what can you tell me when it would have occurred? When you were exactly 5 feet tall. Between 10 and 17 years old? Would you agree with that? Okay, it's sometime between 10 and 17 years old, we were exactly 5 feet tall. Yes? Okay? I mean, if we're all at least above 5 foot, right? Then sometime in your life, you were exactly 5 feet tall, right? But is there any way for you to know exactly when that was? No. I mean, maybe ballpark it if your parents are like, putting it on the side of the wall or whatever if you're marking it. But it makes sense because you kind of grow, not really continuously like a continuous function, but I mean, it would still be a continuous function even if it kind of leveled off, right? You just stayed 5 feet or whatever for a little while. So it does have to do with continuity. So since at some point there was some age between 10 and 17, okay, we don't know what it is, but it would be some number between 10 and 17 that you were exactly 5 feet tall, because 5 feet tall was between 4'6" and 5'7", right? Can you guarantee? So at 17, did we say 17? Oh, because you're 17. I was like, it says 17? I was like, where's 17 come from? We can pretend like it says 17. Let's pretend like it says 17. So let's say you're 17 right now and you're 5'7". Can you guarantee at some point you are going to be 5'10"? No. Okay, if you're a girl, you can pretty much guarantee that you're not going to be, just because girls, you're pretty much done growing. Boys, you're going to continue to grow. You can continue to grow until you're like 27. Okay? Probably not a ton more, but like your feet will continue to grow, your bodies can, yeah. So no guarantee that you will, but you could. So even if you're a guy, you can't guarantee that you're going to be 5'10", because maybe you keep growing, but you don't grow to 5'10", right? Because that 5'10" is not between the 4'6" and the 5'7" that we actually have information on. You with me on that? So we can guarantee that it exists. We can't guarantee something doesn't exist, though. So we can't guarantee that we'll never be 5'10". Maybe we are, maybe we aren't. But the intermediate value theorem is a theorem that it's called what's called an existence theorem, okay? So that says this is the concept between the intermediate value theorem. And this is what this says. IVT, which we will be able to abbreviate it to that. Okay, so if F is continuous, that's the most important part, and we just talked about continuity, continuous, on the closed interval from A to B, where F of A does not equal F of B, right? So A and B, those are my X values. The F of A, F of B, those are my Y values, right? So whatever my inputs are different, my outputs cannot be the same. And K is a number between F of A and F of B. Then there is at least one number C in this interval such that F of C equals K. Okay, so this is one of those wordy math things, and it's not nearly as bad as what I showed, what we're doing in pre-cal right now. We're talking about polynomials, and just as a little throwback here, this is the definition of a polynomial, And anytime I show that to anybody, you freak out. Like a polynomial is 2x squared plus 3x plus 5, right? But like this wordy stuff, it looks horrific, but polynomials aren't that bad, right? But here, even this, it's kind of wordy, and I know that you might have to take a minute for it to kind of sink in. What really matters is that you know how to use it. But the reason I'm saying this is you've never, most likely, never had to learn math from a math textbook without somebody actually explaining things to you. And it is possible when you get into college that your professor may refer to a textbook a lot and expect you to read a math textbook section to try and like get ahead or understand it. So you can't let wording like this freak you out. I get it if you don't understand it 100% the first time you read it, because the first time you read it, you're just like, that's a lot of letters and a lot of things, right? But just keep that in mind. So we want to make a little bit of sense of what this says, but then it'll get better once I explain it, I promise. So the function is continuous. We have a closed interval. Our outputs of the interval can't be the same. K is some number, because we have to make things generic in math, right? So K is some number between f of B and f of A. So K is an output, K is a Y value. The Y value that I'm looking for, my height, right, or my age, is between these two right here. Then there has to be at least one number in here such that f of C equals K. So what we're saying is this. If 5 feet is between the 4 whatever and 5 whatever it was, then, and my age is between 10 and 17, then there had to be a time between there that it would work. Okay, it has to do with continuity, and it's like the only thing that makes sense. Think about your growth right there. Okay, so what does the word intermediate mean? Anybody know? Honestly, I was going to look up the definition to make sure I had it right, but basically what we're getting at here, what we're implying is in between. Intermediate is like in between. Is that what you were thinking? Something like that? Intermediate school is between middle school and high school. It's the middle. Okay. So IBT is about showing a point exists between two values. Okay. Between two values. So IBT is called an existence theorem, which means we can prove that it exists. We can't use it to prove something doesn't exist. So we will learn 3 of these theorems in AP Calculus. We have IBT, MBT, and EBT, but we're starting with intermediate value theorem, and then we'll kind of look at them all together. Okay, so when we first do this, when using the theorem, we must first show that the conditions are met. And that's anytime you're using a theorem, you have to show that the conditions are met. Okay? So we have 2 conditions. First one, we already know how to do it. The function must be continuous. We just talked about continuity, right? Continuous on the given interval. And it'll be given to you. Okay? Got to be continuous on 1 to 3 or whatever it is. Condition 2, which is very simple. So IBT is actually a very simple concept. We just got to get all the wording in there right for the explanation is the main thing. So the Y value, whatever our output is, Y or F of 5 or whatever it is, we want to guarantee must be between the Y values at the endpoints. Okay. Like I said, the overall concept will kind of will make pretty good sense. The work behind it is fairly simple. Then we just got to make sure we say all the right words, and then we're good. Okay. So here's another cool thing here. AP problems rarely explicitly ask you to use the IBT. You have to know that that's what you want to do based on how it's asked. Okay, so you have to recognize the wording. Below are a few examples of the wording. These are just examples that will imply, but I think you'll kind of get to that. Must there be? Can you guarantee? Show that there must. Does a value exist? That sort of thing. All right, so here's how we apply IBT. We are going to find the function values. This link isn't long enough, but function values. Well, maybe it's long enough. I can't write smaller. Maybe I'm not close. Okay. So we find the function values. We find if my endpoints are a and b, I find f of a, f of b. Sometimes it's a chart, and I don't even have to do any work. I just have to write it down. Then we have to show that the requested y value or function value is between, okay, and I'm going to abbreviate between, BTWN. Good with that? You can write it out if you want to, but that's what that means. Then it says to make sure, you have to actually state, not just make sure, state the function is continuous on the interval. And then you invoke IBT by using the following conclusion. Okay, so I'm going to put a little star here because this is one way to say it. I think that it's my opinion that I like to write it a different way than this, so there's nothing wrong with this, really. It's just you can say things different ways. So, and I think overall, because I tried to, as I was writing them out, and I went and checked with Mr. Ackerman, and I know that Miss Bruce, have I talked to y'all about Miss Bruce? So she, or any of y'all in AP Stats last year? Okay, so she is the AP Calculus, she's the AP Math lead for the district. She teaches AP Calculus BC, AB, and AP Stats at Pasadena High School. She's a rock star. I want to be Miss Bruce when I grow up. Anyway, last year when it was my first year to teach calculus, she came every Thursday. She and I would sit for about an hour before fifth period because I'm off fourth period. And we'd talk through the notes or talk about whatever. Sometimes we just talk. But then she would most of the time just teach my fifth period. I just learned from her. I'm like, and after a while I was like, I did want her to watch me teach once and like give me some feedback. But then I was like, my kids are missing out on her expertise. But anyway, so she's like somebody I know I can trust. She's read the test, which means she's graded it for years and years, so she knows what's okay and what's not okay. So anytime I can't answer the questions like, what if I wrote this? Would this be okay? And if I'm not sure, I can ask her because she knows. So I'm saying all that to say this. This isn't how she writes it either. So I don't want you to think it's just like my opinion. She writes it the other way as well. But this is coming from a different calculus guru. So there's just more than one way to do things. But we could say since f of x or whatever it is continuous on the interval, the IBT guarantees that, and then you can just reword things. But again, I'm not going to mark this out. I started to have you rewrite a different one, but I feel like when we do that, there's lots of blanks and variables. It makes it just as confusing as the thing at the top. And I think if we just have some examples for you to follow, that's going to probably be better, like real numbers and real words. So let's flip the page and let's look at this, what we're doing. I'm not going to send you to the boards and make you do this today because I think that it would just be a hot mess of stuff. Because you don't have any background knowledge really for this. So the function f of x is continuous with the selected values of f of x shown in the table above. Is there a value c with c being between 1 and 7 such that f of c equals 0, and we have to justify our answer? Now, I personally think that it's really better for you to write your intervals in interval notation and not with the little greater than, less than, because those get mixed up a lot, all right? So even if it's written like that for you, you don't have to do that. Like isn't this the same thing as 1 to 7 like this? It's the same thing, right? And so even though it's written like that, if you're going to use this in the answer or whatever, you can write it like that, or you can just repeat that. Either way is fine, okay? But it means the same thing. All right, so remember our first step, step 1, was to find the function values at the endpoints. So this is my interval, which means I need f of 1, and I need f of 7. So those other VT, I told you IVT, MVT, EVT. MVT, you start this the same way. So like both of these, a lot of the work looks the same, and then it's just kind of how we answer the question that's different. So from this table, what is f of 1? -2. What is f of 7? 6. Okay. Just as another little side note, when you're answering questions on the AP exam, all of your work and everything has to be like under the question that's being asked, but there's not enough room. That's why I'm putting it up here. Okay, and I can't always edit these beforehand, so just throwing that out there. Our notes may sometimes look a little bit different, but I'll make sure when it matters that you have plenty of room. Okay, so I want f of c to be 0. So these are y values. This is a y value, right? Is 0 between -2 and 6? Yes. Okay, is f of x continuous? Is it? It says it's continuous, so the answer is yes. And how do we know? They told us, okay? We don't have to go do the continuity thing. It is that simple, okay? Really is that simple. Okay, so we have to show that it's continuous, and we have to, those were the two big things, right? Right. Oh, dang it. That condition 1, it has to be continuous. They told us it's continuous. Condition 2, the y value we want must be between the other two y values. It is. Both conditions are met, so then we're pretty much done. We just have to explain ourselves. And like I said, there's really not a whole lot of work there. I'm going to, just so I don't confuse you with I'm going to erase what I wrote here, just so it doesn't look like I'm trying to do something else there. Okay, so what we can say is this. We need to say the two things that we had to guarantee. F of x is continuous. Us on 1 to 7, okay? Because they're telling us that, right? And we can use words here. We can say, and 0 is between -2 and 6. Okay? Those are the two conditions that had to be met, right? It's continuous. How do we know? They told us. We don't have to say it's continuous because you told us so. We just say it's continuous, okay? And then make sure we put on the interval. And that 0 that we want to guarantee, that y value is between the other two y values, okay? Then we can say, therefore, there's a little 3 dots for therefore. Then I'm just going to rewrite that question. It says, is there a value c with this interval such that f of c equals 0? So then I can say, therefore, I'm going to say must, because that's one of those words that we like on IBT. There must be a value C on 1 to 7 such that, I'm just rewriting that, f of C equals 0, and then we want to add by IVT. There wasn't even enough room to write all the words, especially not all that, so sorry about that. I need to make some adjustments. I didn't realize that until I wrote it out after they were copied. Okay, we good on that? Make sense? Any questions? Okay. So now the second one, example 2, does not go with example 1, does not go with that table. It says, use the intermediate value theorem to show that g of x, which is this polynomial here, has a 0 on the interval from 0 to 1. So the first thing I have to think of, well, the first thing I want to do is find these values, right? So I'm going to find g of 0 and g of 1. How do I find those? Substitute it in, right? Substitute in for x. So if I substitute 0 in, what do I get? -1. If I substitute in 1, I'm going to get 1 plus 2 minus 1, which is 2. And you don't have to show any work there, but it's not a bad idea to at least write those down so you're not getting an easy number wrong in your head, right? Because you just try to do it quickly. Okay, so I want to show that there is a 0. So if I have a 0, that means I have an x value. My y value is 0, right? Because it's like an x-intercept. So is 0 between -1 and 2? Yes. Okay, so that's condition 2. Condition 1 is that it's continuous. Is this continuous? Yes. How do we know? It's not a piecewise function, and it's not a fraction or a rational, okay? It is a, what was the crazy thing I showed you just a minute? Polynomial. It's a polynomial. It's a cubic, right? And there's some, like, your parent function of a cubic looks like, y'all were totally right. Those are things that, it's not piecewise, so bam, and so I don't even have to check it, right? It could be continuous if it's piecewise, right? We just have to check it. And then it's not a rational function because it's not made into a fraction. And it's just a polynomial. All polynomials are continuous from -infinity to infinity. So even though it doesn't tell us that knowledge of the polynomials is what we need, and we're allowed to just say it's continuous. We don't have to explain why we know it's continuous. It's something we're kind of expected to know at this point. So we don't have to say it's continuous because it's a polynomial or anything like that. We just say it's continuous. We good? So I got my two conditions. So we're going to write those down. We're going to say G is continuous, and I'm abbreviating here, and these are okay. Remember, we can call it G and not G of X. You can put G of X if you want. Just calling it G is fine too. Something that's probably kind of new to y'all. And I may have been doing it along the way and not even realizing it without telling you that it was okay. So G is continuous on the interval from 0 to 1, and 0 is between -1 and 2. Remember what you're looking for. We're not trying to get this between these two because this is an output and these are inputs, right? So this output is between these other two outputs. We're all good with that? So we can say, therefore, G must have a 0 on 0, 1 by IBT. This one has a little less words because we're not a value C on blah 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 is just said a little bit different. You could say must have an X value on this where the Y value is 0, but just calling it a 0 means that we know that has the X and Y and how that works. Yes, sir. Okay, because here this one has brackets, and on here, if this had brackets, it would have the little lines under there. Very good questions, because that means it's an open interval. Okay, very good question. And I can tell by the O's that you weren't the one wondering that, but that's why. And it actually bothers me a little bit that it looks like this because it does say on the closed interval. I mean, that's kind of part of the definition, so I don't know if that's just like a bad way to ask the question or what. No, it kind of asks you on that as well. I can also tell you this, that when we are looking, just in case you see it written out somewhere, like you doing exactly what we did is 100% fine, right? But when I'm looking for, I want to find my Y value to be 0, that actually lives between these two, right? So even though it's telling me on this interval and that's what I'm using, I could say it has to actually be between here. There's some X value between 1 and 3 because this is where it changes and my 0 would be. So you could use different intervals of that. And again, I'm just kind of telling you that if that pops up on a multiple choice question, you're like, why did they only use these two? Because you could narrow it down. Here, not necessarily without us doing some extra work, like what's the point? But if you have a table, sometimes you can kind of narrow it down. You don't need to, but you can. Okay. All right, we good? All right, so let's look at this one. So it says the functions h and k are continuous. Selected values for h and k are shown in the table below. Let m be this function. M of x is equal to k of h of x. Can you guarantee a value c? So seeing this, can you guarantee a value c such that this exists? That's when you go, ooh, that means it has to be IBT. That's your only option right now as far as these are concerned, but that gives it away, especially if you have more than one type of question coming on. And of course, give a reason for your answer. So the first thing I want to do, and we're using m, I mean, we have h and k here, but we're using m, so we need to find m of endpoints. I need m of 1, and I need m of 9. Okay, so m of 1, since this is my m function, that's going to be k of h of 1. What do I do? Freak out and stop? Absolutely. Okay, we're done. Type this in. What do I do first to figure this out? Do I do the k first or the h first? H, you work from the inside out. What is h of 1? 5. So what this really is then k of 5, because h of 1 is 5. And then what's k of 5? K of 5 is 7. Follow that? All right, so you find m of 9 then. I'll give you a second to make sure you can think through this, okay? Do we agree that it's 1? Okay, beautiful. All right, so I have my two values. I want to guarantee that there is a y. So these are my two y values. I want to guarantee that the value of 4 is between the two. Is 4 between the two? Yes. Okay, is M continuous? Yes. Do they tell us that? No. What do they tell us? H and K are continuous, right? They don't actually tell us that M is continuous. But if you have a composition of continuous functions, you're going to get a continuous function. Okay, so we just have to make sure that we state that when we do this. So here's what we're going to say. We're going to start with M is continuous on 1 to 9 since H and K are continuous on 1 to 9. And I change it from the inequality to this more just because I'm lazy, but you can do it either way. All right. Now, is that enough? What else do we have to say before we can say therefore? We have that it's continuous, then we have to say the y value we're interested in, which is 4, is between, or the output, it's not always y, but the output value is between the two output values we found, right? So then we can say and 4 is between 1 and 7. Okay, so we have that it's continuous. We have that our y value or our output value is actually between the two that we found. Then we can say, therefore, there must be, or you can say we guarantee, I'm just going to say there must be. I just like that better. There must be, and then I'm just going from here, value C on, or you can say where, but again, 1 to 9, such that M of C equals 4. This one has a whole lot more writing than a lot of our explanations do, but it also has a whole lot less work, so it's kind of a trade-off. Yes, sir. You have plenty of time. Off the top of my head, I don't remember the actual numbers. We can talk about that tomorrow. I'll make a note of that, and then we'll, because that is a good question. You really do have plenty of time, and what I can tell you is the way that the FRQs work is you have two that are, or you have 2 or 3. Oh, good Lord. I'm going to lie. Hang on. Never mind. We're going to talk tomorrow because now I can't remember the numbers. I have the AP pre-cal stuff in my head, too, which is different, and so now I've got them all confused. Because here's what I can tell you for sure off the top of my head, since I'm confused with 2 different pieces of information, is that each FRQ is worth 9 in calculus and 6 in pre-cal. But there's different numbers of FRQs, and now I don't remember what's what. We'll talk about the way it's set up tomorrow, because that is a good question. But you really will, if you run out of time, it's because you're staring at it and you're clueless, not because you don't have enough time to actually go through it. You know what I mean? Not necessarily clueless, but you know what I mean. If you have to spend a lot of time just sitting there and your anxiety takes over, whatnot. If you can sit down and you'll still have time to think. Also, you really shouldn't feel rushed. I mean, that's just kind of the observations I've made.